In this lesson, you are going to understand the concept of recommender systems. By the end of this lesson, you will be able to build a recommender model using Python, describe the mechanism of association rule mining, demonstrate a priori algorithm. So let's go ahead and understand recommender systems in detail. So what is a recommender system and how is it useful? Many e-commerce and retail companies implement recommender systems on their websites to leverage the power of data and boost their sales. In other words, the goal of a recommender system is to predict users' interests and recommend products that the users may be interested in. Data required for recommender systems stems from explicit ratings that users provide after watching a movie or listening to a song, from implicit search engine queries and purchase histories, or from other knowledge about the users, items themselves. Recommender systems are one of the most successful and widespread applications of machine learning technologies in business. It is an information filtering technique that provides users with recommendations that they might be interested in. As you can see in the given image, interests of users A, B, C, D are given. Your recommendation system has to find out whether user E will be interested in music or not. Let's look at how recommendation systems are useful in day-to-day life. Recommendation systems act as a solution for many of your day-to-day choices, such as which website will you find interesting, which degree or university is best for your future, which is the best investment for supporting the education of your children, which digital camera should you buy, which book should you buy for your next vacation, which is the best holiday for you and your family. Before we explore this topic, let's think of how a recommender system recommends items to users. It recommends items that are more popular among all the users. It divides users into multiple segments based on their preferences, that is, user features, and recommends items to them based on the segment they belong to. In the given example, you can see that when you go to buy a book on Amazon, it recommends books that are frequently bought together, and also gives you insights under customers who bought theirs also bought this. Let's understand the purposes of a recommender system. Prediction perspective. It predicts to what degree a user likes an item. It is the most popular evaluation scenario in research. Interaction perspective. It educates users about the product domain. Conversion perspective. It looks for commercial situations, such as increase in hits and click-through, and also checks lookers' and bookers' rate. Retrieval perspective. It reduces user search cost and effort by providing correct proposals or recommendations. Recommendation perspective. It identifies items from long tail where users don't know about their existence. Paradigms of recommender systems. Recommender systems reduce information overload by estimating relevance. As shown in the given image, a recommender system matches the relevance of the recommendation component with the recommendation list, and based on the relevance, it decides the recommendation. What are personalized recommendations? The most relevant item is recommended based on the user profile and contextual parameters. Every day, massive amounts of information are generated, and the existence of a large amount of information makes it difficult to find the required information. Personalized recommendation is the process of alleviating the problem. Now, let's understand how a recommendation system finds what's popular among your peers. Collaborative filtering recommendation algorithm uses the rating data to calculate the similarity between items. It does not consider the semantic relationship between different items. Let's understand what content-based recommendation is. It is used to display products similar to the products you have liked before. A content-based recommender works with data provided by the user, either explicitly, through rating or implicitly by clicking on a link. Based on the data provided by the user, it generates a user profile. Suggestions are given to the user based on this. The recommendation engine becomes more and more accurate as the user provides more inputs or takes action on the recommendations. Knowledge-based recommender systems use knowledge about users and products to make recommendations about which product meets the user's requirements. A knowledge-based recommender system does not have a ramp-up problem as it does not create recommendations based on user ratings. Since knowledge-based recommendation systems' judgment is independent of individual tastes, it does not have to gather information about a particular user. These characteristics make knowledge-based recommenders not only valuable systems on their own, but also highly complementary to other types of recommender systems. Let's now understand how your recommender system can make combinations of various inputs and/or composition of different mechanisms. Hybrid recommender system is a system that combines content-based filtering and collaborative filtering and takes advantage of both the representation of the content as well as the similarities among users. It is also possible to use the recommendations of the two filtering techniques independently. Collaborative filtering Part A. Collaborative filtering systems make recommendations based on historic preference of the user, such as items clicked, watched, purchased, liked, rated, etc. User item matrix can be used to present these preferences. It uses filters either based on item-based nearest neighbor or user-based nearest neighbor. Let's understand user-based collaborative filtering. Well, user-based collaborative filtering recommends items by finding users similar to the active user, as in the given example. Based on other users, you need to determine whether Alice will take the buy 5, which is not seen or rated by her. Let's understand how you can measure user similarity using Pearson correlation. Degree of linearity can be determined using Pearson correlation. In other words, it determines whether there is a linear component of association between two continuous variables. As such, Pearson's correlation has no assumptions about linearity. However, when you already know the relationship between your two variables is not linear, you would normally not want to pursue a Pearson's correlation to determine the strength and direction of a linear relationship. Let's understand the given formula. In the given formula, A and B are the two users, and you are asked to find the similarity between them. The given formula will give you the result between -1 and 1, where 1 means highly similar and -1 means not at all similar. In the given formula, A and B are users. RAP is the rating of user A for item P. P is the set of items that are rated by both A and B. Now you have the similarity between different users for a specific item. Use these similarity values in making predictions. So a common prediction function is given on the screen. Here, sim AB is the similarity value obtained for users A and B. RBP is the rating of user B for item P.